Hi everyone, this is your math guru. Today we're going to learn the geometric progression or geometric sequence. In the course of this video, I will refer to it as GP. If you like this video, please click on the subscribe button below for more easy to understand math concepts. A geometric progression is a type of sequence where each term is found by multiplying the previous one by a fixed non-zero number called the common ratio. In this example, we have the sequence 3, 6, 12, and 24. To get from 3, to move from 3 to 6, I'm going to be multiplying by 2. To move from 6 to 12, I multiply by 2. And to move from 12 to 24, I'm going to be multiplying by 2. The first term here, I'm going to call it term 1, which is 3. The second term is term 2, which is 6. The third, 12, and the fourth, 24. If I'm going to move from term 1 to term 2, which is from 3 to 6, I'm going to be multiplying by 2, like I showed earlier. Thus, the first term, which is 3, is referred to as our T1, which is our our A. The R, which is a common ratio, can be found by dividing a term by the previous term. For example, in this example shown, or in this sequence, to get a common ratio, which is our R, we have T2 divided by T1, or it's also the same as T3 divided by T2. It goes on in that manner. So in summary, our R is Tn divided by the previous term, which is Tn minus 1. And for this example, my R is T2, 6 over T1, which is 3. That will give me 2. I can double check with another value. My T4, which is 24, over T3, which is 12, will give me 24 divided by 12, 2. So once I know my first term, which is 3, if I'm moving from my first term, T1 to T2, I'm going to multiply my first term, A, by 2. So moving from 3 to 6 is A times 2. If I'm moving from my term 1 to term 3, I'm going to have my first term, A, I have times 2 times 2. That will be times 2 to the power of 2. And if I'm going to find the value of my T4, it's going to be the first term, A, times 2 in how many places? 1, 2, 3. 2 to the power of 3. Let's summarize as shown. Using the same sequence 3, 6, 12, 24, my first term is my T1, which is equals to 3. And that is also equals to my A. My second term, T2, equals to 6. And I derived that by multiplying 3 by 2. Or my first term, A, by my common ratio, R. My third term, T3, is 12. I got that by multiplying 3 times 2 times 2, which is 2 squared. And that is the same as my first term, A, times my common ratio, R, to the power of 2. My fourth term, that's 24, is my first term, 3 times 2 to the power of 3. That's 2 in 3 places. And that is the same as my first term, A, times my common ratio to the power of 3. So in summary, my nth term, which is my Tn, is going to be my first term, which is my A, times R to the power of n minus 1. If you note the previous breakdown, is my first term. If I'm dealing with my fourth term, the power of R, or my common ratio, will be 4 minus 1, which is 3. If I'm dealing with my third term, T3, the power of R will be 3 minus 1, which is 2. Or if I have my second term, T2, the power of R will be A to the power of R to the power of 1. There's an invisible one there. In summary, the Tn for a geometric progression, or the nth term, equals A multiplied by my common ratio to the power of n minus 1. This term, or this formula, will be the focus of this video, and I'm going to use it to find the value of any specific term in a GP or to determine the position of any term in a sequence. Let's look at the following example. In my first example, I have considered the geometric sequence 2, 6, 18. A. Determine the general term for this sequence. B. Calculate the value of the 8th term. And C. Which term in the sequence is equal to 1458. The first question says, determine the general term of the sequence. My sequence is 2, 6, and 18. I know that my first term, let me tag each term. My first term is T1, which is also equals to A. This is my T2, and this is my T3. So my first term equals to my T1, which is equals to A, and that is 2. To find my common difference or my common ratio, my R equals T2 over T1. I'm also going to get the same value if I have it as T3 over the previous term, which is my T2. For this example, my R equals T2 over T1. That's 6 over 2, and that is 3. I can also do a double check. T3 is 18, and T2 is 6. 18 divided by 6 is 3. My Tn, the general formula for a GP, is A, that's my first term, times my common ratio to the power of n minus 1. Fitting in the values I have my Tn equals my first term, which is 2, times my common ratio, which is 3 to the power of n minus 1. The second question says calculate the value of the 8th term. Starting with my general formula, I have Tn equals first term 2 times 3, my common ratio to the power of n minus 1. To find the 8th term, my n is going to be equals to 8. So I have T8 equals 2 times 3 to the power of 8 minus 1. And that's going to give me 2 times 3 to the power of 7. If you punch that in your calculator, you're going to have 28 equals 4,374. The third question, which says, which term in the sequence is equal to 1458? Starting with my general formula, I have my Tn equals 2 times 3 to the power of n minus 1. We're trying to look for the term that will give us 1458. That is, we are looking for n. So that's going to be 2 times 3 to the power of n minus 1. I divide both sides by 2 to get rid of my 2 here. This cancels. I'm left with 729 equals 3 to the power of n minus 1. Because I have this in base 3, I'm going to convert 729 to base 3 using prime factorization. You can check out my video on prime factorization, but for this question, I'm going to quickly work this out here. Because I want to change to base 3, I'm going to be dividing by 3. 3 in 729, that's 243. I divide by 3 again, I'm going to have 81. I'm using the long repeated division method. 3 in 81, I have 27. 3 in 27, I have 9. 3 in 9, 3. 3 in 3, 1. So 729 here is going to give me 3 to the power of 1, 2, 3, 4, 5, 6. 3 to the power of 6. I'm putting that back into my question. I have 3 to the power of 6 equals 3 to the power of n minus 1. And because the base are the same, I'm going to be equating the powers. So I have 6 equals n minus 1. If I move minus 1 to the other side, I'm going to have n equals 6 plus 1, which is 7. So the term that will give me 1458 is my 7th term. Let's look at another example. In this example, we have the first 3 terms of a geometric sequence are x plus 2, 3x plus 1, and 7x minus 1. They're all expressions. Determine the value of x. If I tag each term, this is my term 1, this is my term 2, and this is my term 3. And because it's a GP, what I know that have a constant value is my R, which is the common ratio. And to find my common ratio, I know that my T2 over T1 must be equal to my T3 over T2. Slotting in the values, we have T2, which is 3x plus 1 over T1, which is x plus 2, equals T3, 7x minus 1 over T2, 3x plus 1. To make it a linear equation, I'm going to cross multiply. And if I cross multiply, I'm going to have 3x plus 1 times 3x plus 1 equals 7x minus 1 multiplied by x plus 2. If you fall on each side, I'm going to have 9x squared plus 3x plus 3x plus 1 equals 7x squared plus 14x minus x minus 2. You can pause the video and expand yourself to see. If I collect all the like terms, I'm going to have 2x squared minus 7x plus 3 equals to 0, making it a quadratic equation. And if I factorize, I'm going to have 2x minus 1 and x minus 3. Therefore, my x is going to be 1 over 2, or my x is going to be 3. Thanks for watching. Bye.